5.9, write polynomial functions and models. Heads up, there is going to be, out of these 4 examples, one of them absolutely requires a graphing calculator. It's a statistics example. And one problem highly recommends a graphing calculator because you're going to have to solve a system of equations with 4 variables and 4 unknowns. If you thought 3 variables and 3 unknowns takes a while, 4 by 4 takes a lot longer without a calculator. Start off with something pretty friendly. It says write the cubic function whose graph is shown. Well, we're given zeros, so we can start by writing out those factors. X plus 4, x minus 1, and x minus 3. That could all be multiplied by some constant. We don't know what that constant is until we use our extra piece of information. That tells us how much it stretches out. It says if we plug in 0 for x, we get -6 as an answer. So we do that. Turns out we end up with 12a equals -6. So a is -1/2. And we can write out our final solution with a plugged in. And we're done. We don't even have to expand that out because it doesn't say to write it in standard form or anything like that. Next up, it says the first 5 triangular numbers are shown below. You can kind of see from the picture why they're called triangular numbers. A formula for the nth triangular number is given. Show that this function has a constant second order differences. So let's talk about what differences mean. If I take my 3 minus 1, I get 2. If I take my 6 minus 3, that's 3. 10 minus 6 is 4. 15 minus 10 is 5. Because I took differences of the original problem, these are called first order differences. You can probably see a pattern there. Now if I do it again, I get 1 every time. This is called the second order differences. And the problem says show that this function has constant second order differences, meaning they're all the same. And you can see that they are all the same. They're all 1. That's it. This is kind of an intro to the slightly harder problem we're going to see. But what we're supposed to know coming out of this example is the second order differences are always constant in a second degree equation. If we were looking at a third degree equation, we'd have to find the third order differences. For a fourth degree equation, the fourth order differences, and so on. And that's what this next slide kind of talks about. Not yet. Go ahead and try these on your own or do them later. This slide tells us about differences. It tells us if a polynomial has degree n, whatever n is, then the nth order differences are always equally spaced and constant. So we saw that in the last example. Conversely, if we know that the nth order differences are equally spaced, then the data can be represented by a polynomial function of degree n. So in other words, if we know that the 5th order differences are all 7, then this must be a 5th degree equation. So let's see what that's going to look like in a problem. It says the first 7 triangular pyramidal numbers are shown below. You can kind of see why these would be called pyramidal numbers. They make little pyramids. Find a polynomial function that gives the nth triangular pyramidal number. So this is going to be a beast of a problem. First, you have to find those common differences. Go ahead and try that on your own until you find the common difference that's the same all the way across. That'll tell you your degree. They're not all the same yet. Still not all the same, but I'm seeing a pattern. And there we go. So this must be a not first, not second, but a third degree equation that's going to fit all of these numbers. So you've got to come up with that third degree equation. And that's going to be the part that's really hard without a graphing calculator. We know that because this is a third degree equation, we can start off with something like this. And because there are 4 things we don't know, we're going to have to set up an equation with 4 variables and 4 unknowns. That means we have to plug in numbers 4 times. So maybe I'll choose, doesn't matter which ones I choose, I'm going to choose the ones with the smallest numbers. I'm going to plug all of these in to this equation. Go ahead and try that. You'll pause and see if you can come up with the 4 equations I come up with. I'm really just plugging in the numbers. These are the 4 equations I get when I plug in my first 4 ordered pairs. At this point, I could try to eliminate different things and try to solve for A, B, C, and D. I would probably take a long time to finish. Instead, I'll use my graphing calculator to set up some matrices that'll solve this for me. Go back to chapter 3 if you don't remember this part, or check the graphing calculator supplement. That might be enough to get you going. And you'll get your 4 answers for A, B, C, and D after you plug all those numbers in. And it turns out that A is 1. Not ready yet. If you do all that, you'll figure out A, B, C, and D, and you can use that information to write your final answer. Again, you don't have to have a graphing calculator to do this, but I have pity on anyone who tries doing it by hand. It's kind of an insane problem. Turns out D was 0, so there's nothing to write for that one. At this point, you can try this on your own or do that later. Hey, this next problem requires a graphing calculator. We're doing some regression using some stats information on the calculator. Check the tutorial in the resources. You're going to end up putting some data into a table and try to figure out a line that best fits. So nothing to say on that one other than what you should get for a final answer I'll put up here. For those of you that think you can muddle through it without the tutorial. Turns out that the equation that best fits all of this data is given by this right here. 4th degree. You could have also used a 3rd degree equation. And the value of x that we care about ends up being 101.3 seconds. Again, check that supplemental information for how to use the calculator to come up with an equation that best fits data. That's something you'll be doing a lot in statistics if you decide to go that route. At this point, you can try one more of those on your own, or you can do that later. Other than that, we are done with chapter 5.